Welcome to Brain Vision.
You're looking at the expansion of a glass rod inside of a laser with a temperature change of 65.0 degrees Celsius. So first we want to look at how the length changes of the rod. So delta L is equal to the average linear expansion coefficient alpha times the initial length times delta T. This one's easy, just plug in some numbers here. 9.0 times 10 to the negative 6 inverse degrees Celsius. Initial length is 30 centimeters, but this is also going to be equal to 0.3. I'm just going to write meters so that's clear. And the change of temperature was just 65.0 degrees Celsius. And you should find that the change of length of the rod is equal to 1.76 times 10 to the negative 4 meters, which is the same thing as 0.176 millimeters. To put that in perspective. Okay, so for part B, we're going to look at how the diameter changes d. So we know di is 1.50 centimeters, and we can kind of rearrange our initial equation for the diameter. So delta d is equal to alpha, initial diameter, times change in temperature. Again, just plug in numbers. -6 for our initial diameter. Instead of 1.50 centimeters, that's about 0.015 meters. And our change of temperature is 65.0 degrees Celsius. And you should solve that the change in diameter is equal to 8.78 times 10 to the negative 6 meters, which is another way of writing 8.78 micrometers. Now, how does the volume change? Well, we can start with the equation delta V is equal to 3 alpha V initial delta T. But we need to find our initial volume in order for this to work. So the volume of a cylinder is going to be the area of the base, which is just pi r, but we have diameter, so the diameter over 2, and this is the initial diameter, squared, times the height of the rod, or length, Li. So let's just plug in our numbers again. Pi, di is 0.015 meters, and over 2 squared, initial length was 0.3 meters. So you should find that the initial volume, Vi, is equal to 5.30 times 10 to the negative 5 meters cubed. Okay, let's plug that into our equation now. Delta V is equal to 3 times the average linear expansion coefficient, which is 9.00 times 10 to the negative 6 inverse degrees Celsius, times the initial volume, 5.30 times 10 to the negative 5 meters cubed, times the change of temperature, 65.0 degrees Celsius. And if you work it out, you should find that the increase in volume is 9.30 times 10 to the negative 8 meters cubed.